An investment will pay you $100 at the end of each year of the next 3 years, 200 at the end of year 4, 300 at the end of year 5, and 500 at the end of year 6. If investments of equal risk earn 8% annually, what is the investment's present value and its future value? So what this question is telling us, we will receive a cash flow, or receive at the end of year 1 $100, end of year 2 another $100, end of year 3 $100, end of year 4 $200, at the end of year 5 $300, and at the end of year 6 we'll receive a final payment of $500. What we then want to find out first is what is the present value of this cash flow. That is, these are future values that we're receiving, and we want to know what they're worth today, given a discount rate of 8%. The next part of this question is then to figure out the future value of this cash flow. That is, what is this amount going to add up to at year 6 if we take the cash flow received at year 1 and let it grow at 8% for the next 5 years, and then the 100 at year 2, let that grow for 4 years, and so forth. Okay? So we know the formula for PV. PV is equal to the future value divided by 1 plus the discount rate to the power of t, or the number of time periods. So simply, we'll take equal sign, and we'll reference our cash flow of 100, which is a future value, and then we're going to divide that by 1 plus the discount rate. Using Excel, we're setting this up to where we can just drag the formula, so we'll want to hit F4. Next, we're going to reference the respective time period. So we're 1 period into the future, which means we need to discount by 1 period. We see that this $100 received 1 year from now has a present value of approximately $92.60. We can then drag this formula down, and we notice that in year 2, our $100 now is only worth $85 and change today. And at the end of year 6, the $500 is actually only worth $315 today. We then sum these values to find a present value of all of the future cash flows. And we find that these cash flows have a present value of $923.98 approximately. The next thing we need to consider is the future value. We want to find out what are these cash flows going to be worth at the end of year 6 if we let them grow. Now, since these cash flows are obtained at the end of the period, we can then realize that, well, there's no time for the last cash flow to grow. That is, there's a total of 6 periods here, and then since we're subtracting from the end, what do we have left is 0. And the way to do this is simply, well, our final period here less the reference period. And so we see for the last payment, well, there's no growth. Then we'd expect for the cash flow that's received at the end of year 5, it's going to have 1 period of growth. The cash flow at year 4 will have 2 periods of growth. And we can just drag this equation, or this formula, the whole way up. So we see our cash flow received at the end of year 1 will grow for 5 years by the time we receive our payment at the end of year 6, which is $500. So how we can set this up is we can say, well, these are present values that have a certain amount of time to grow till the end of year 6. So we say equal sign our present value times 1 plus our discount rate to the power of time t. Now we can use the 5 that we have set up there, or we can just impose the formula that's within this cell. So we can see that the cash flow that we receive at the end of year 1 will grow to $146.93 by the time we get to year 6. We can simply add these values, and we find that we will have a future value of $1,466.23, maybe 24 cents at the end of year 6. That's if we receive the cash flows at each of the respective periods and then invest them at 8%. We can also solve for the present value using the NPV function in Excel. So we simply type in $NPV in parentheses. We first reference the discount rate, and then we just select the cash flows, that is the undiscounted cash flows. Recall that in Excel, the first time period is always referenced at year 1, so we don't actually have to reference a value at time 0. By default, Excel looks at the first cash flow as occurring at year 1. So fortunately, our values add up then. The future value is a little bit more tricky. So we need a rate, 8%, and then we know that this amount is going to grow for 6 years. We're going to assume that we're making no payments over time, but today we know we have a present value of $923.98. And by default, it's the end of the period. So we can see this negative value corresponds over here. The only difference is for the net present value, we could reference it as a cash outflow at time 0 to see how much we would get back at time period 6. So hopefully that helps clarify how to solve for the present value and future value where our cash flows are dissimilar.